So for this question, we're talking about a lineup of people to purchase tickets, 10 people. And so we're interested in how many different ways they could be lined up. So really, how many different ways? That's just really saying how many different ways can they be in order. So order clearly matters here, and that identifies it as a permutation problem. Now, before we jump into that, let's just identify that we could use our fundamental counting principle for this problem. We could identify it as, well, we have 10 tasks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And our 10 tasks are identifying those 10 people. So for the first person, we have 10 to choose from. And we have to choose the second person. And the second person, well, one person is already used up. They have that first position. So we have 9 people to choose from for the second position, and 8 for the third, and so on and so on and so on. And that works perfectly fine. And so you end up multiplying all those numbers out, and you'll get the right answer. But identifying it as a permutation problem with 10 items, in this case people, ordered in the different ways, so all 10 of them being ordered in that way, just leads us to having a factorial here. So 10 factorial. And if we think about it, well, 10 factorial is by definition that very same thing. So this is where we see the overlap of our two methods. But certainly in this case, we look at it and we say, well, plugging in 10 factorial into our calculator, that's a little nicer. So we do that, and we would come up with 3,628,800. So how many different ways can we put those 10 people into order? Well, surprisingly, perhaps, over 3.5 million different ways.